Hello everybody, welcome to your first Algebra 2 video of the year. I'm Mr. Hedrick, and today we're going to be talking about how to simplify exponential expressions with 5 different rules of exponents. And what I want to do first is just to give some introductory background to what exponents are. I always like to work from the ground up. So I have an example on the board here which gives some vocabulary that we'll need to keep in mind, and that is the idea of a base and an exponent. And the example I have is 9 cubed, or 9 to the third power, or 9 as the base with an exponent of 3. What this means is that I'm going to want to take my base and multiply it by itself the number of times that my exponent tells me to. So in this case that would be 9 times 9 times 9, 3 different times, and if I do simplify that, I find my answer to be 729. So base, exponent, these are terms that you're going to need to know. And what you're going to find is that we have 5 different rules of exponents for today's lesson that work not only for numbers, but also for variables. So I'm going to show you an example of each type of rule and how you would apply it to both numbers and to variables. Our first rule is going to be the product rule. So this is when we have 2 different numbers, but they both have the same base, even if they have different exponents. So in this case, you'll notice that my base for both of these different numbers is x, and they have different exponents. One has a 3 and one has a 2, but they do have the same base. And what the product rule for exponents says is that we can take our exponents of this base and add them together. So in this case that would be 3 plus 2, which would give me an answer of x to the 5th power. So that's what our product rule tells us. I'm also going to show an example of how that works with numbers. So here I have an example of 2 to the third power times 2 squared. I'm going to show you how to simplify this in more than one way, but both will give you the same answer, and this will show that the product rule works. So according to our rule, we should be able to add our exponents here because they have the same base, right? The base is 2 for both of the exponents, therefore that's 2 to the power of 3 plus 2, which is 2 to the 5th power, okay? And 2 to the 5th power, 2 times 2 times 2 times 2 times 2, that's going to equal, if you check that in a calculator, 32. Now a different way I could have solved this problem would be to simplify 2 cubed first, and then 2 squared first, and then multiply those two numbers together. So 2 cubed, that would be 2 times 2 times 2, okay? That's going to give me an 8, and 2 squared, or 2 times itself, right? 2 squared is 4. What you'll notice is that if I take 8 times 4, I also get 32. So what this means is that the product rule holds, it works, and I can always take my exponents and add them together. That's very important when we're working with variables. That's our first exponent rule. Our second exponent rule is called the quotient rule. Okay? Instead of multiplying 2 numbers that have the same base, what happens if we divide 2 numbers that have the same base? Now they do have different exponents once again, but as you might suspect, instead of adding our exponents, we're going to subtract them. Numerator minus denominator. So that's going to be x to the power of 3 minus 2, right? Numerator over denominator exponent. And that's going to give me x to the 1st power. And anything to the 1st power is just that same base. In other words, x. Okay? 9 to the 1st power is 9. X to the 1st power is x. So that would be the simplest way to write your answer. Same thing over here. Okay? There's multiple ways that you can approach solving these problems with numbers. With variables, you do have to use that rule. And let's go ahead and prove that. So using our quotient rule, we should find that 2 to the power of 3 minus 2, okay, 2 to the 1st power, 2 to the 1st power is itself, 2. Okay. Another way that you can prove that this rule works is to first simplify the numerator. Okay. 2 cubed, we already said that equals 8. So this is another way of simplifying the problem. And 2 squared in your denominator equals 4. 2 times 2 is 4. What happens when you divide 8 by 4? You also get 2. So what this does is to show that the quotient rule holds, it works. what we can do anytime we're dividing two numbers with the same base is to take those exponents and subtract them, numerator minus denominator. That's our second exponent rule. Okay. Third exponent rule that we're going to cover today. This is called the zero exponent rule. What happens if I have an exponent of 0? Okay. What you will maybe be surprised by is that this answer is always going to be a 1. Always, always, always. At least unless the base is 0, then we would have to talk about that. But in normal cases, whenever you have an exponent of 0, the answer is 1, not 0. Now, why is that? What I'm going to do is show an example, okay? And instead of doing x cubed divided by x squared, let's see what happens when I do x cubed divided by x cubed. Now, what we find normally is that when we divide a number by itself, that answer is 1, right? 4 divided by 4 is 1, 2 divided by 2 is 1, x divided by x is 1. X cubed divided by x cubed is also 1. You're dividing that number by itself. However, if we held off on that for a minute, okay, held off on the fact that this equals 1, what we could have done instead is to show that we can use the quotient rule again here, right? We can take our numerator exponent and subtract it by our denominator exponent because these numbers have the same base. So that would be x to the power of 3 minus 3, which is x to the power of 0. In other words, x to the power of 0 equals x cubed divided by itself, or x squared divided by itself, any number divided by itself, and of course all of this equals 1. So anytime you have a power of 0, that's going to equal 1. This is no less true for numbers than it is for variables. Once again, if I took something like 2 cubed over 2 cubed, okay, I could just simplify that immediately. Anything divided by itself is 1, or I could also use the quotient rule, rule number 2, take my exponents, subtract them numerator minus denominator, and see that I get 2 to the power of 0, which is 1. Okay? So that's our third exponent rule. Our fourth exponent rule is going to be called the power rule. This is when we take a number and multiply it by itself. So what happens in this case? Well, instead of either adding or subtracting, we're actually going to multiply. Think power as powerful. You're multiplying here. In other words, okay, there's going to be 3 times 2, which is going to be x to the 6th power in this case. Now, why does this work? Well, think about it. We're really being asked to multiply x cubed times itself, right? In other words, another way that we could have solved this problem is to take x cubed times yet another x cubed, 2 of these x cubes, right? Just like we had our earlier example where we had 9 to the power of 3, and we multiplied 9 times 9 times 9. Same thing here, we're being asked to take this number inside the parentheses and multiply it by itself 2 times, okay? So what happens? X cubed times x cubed, that's just the product rule again, right? We have 2 different numbers, but they both have the same base. In fact, in this case, they have the same exponent, and 3 plus 3, following our product rule, also equals 6. So multiple ways to approach this problem. The easiest, I think, is to take your exponents and multiply them together to give you x to the 6th power. Let's go ahead once again and prove this with numbers as well as variables. Okay. So one way to solve this problem here, 2 cubed raised to the 2nd power after that would be 2 cubed times 2, which would be 2 to the 6th power. And if you multiply 2 by itself 6 times, you should find that your answer is 64. Now, that's one way to simplify the problem. With numbers, there are multiple ways to approach it. So we could have also, instead, simplified inside the parentheses first. Okay? So 2 cubed, 2 times 2 times 2 would be 8. And 8 squared, 8 times itself, also would equal 64. So this is why the power rule holds. It works. Whenever you have a number inside of parentheses and you're being asked to raise it to another power, distribute that exponent inside the parentheses. That takes us to our last rule for today, which is what happens when we have negative exponents. So, the first thing that I'm going to ask you to remember is that whenever we have a number, it's really the same thing as if we're dividing that number by 1, right? 2 is the same thing as 2 divided by 1. X to some power is the same as that divided by 1. When we divide by 1, it does not change the number that we have started with. But that's going to be important in this case because whenever we have a negative exponent, what we're going to want to do is to move that exponent and its base into the opposite location of where it starts from. So in this case, I'm asking you to move this x to the negative third power, move that into your denominator. Okay. Now what does that leave behind? It leaves behind a 1, right? And when I move that down here, 1 times anything will be the same thing. But what this does is to change your exponent from negative to positive. And if we instead, so this is one way to look at the problem, if we instead had a negative exponent problem that had our negative exponent starting in our denominator, so an example of that would look like this. Okay. Notice that our negative exponent is in our denominator. Once again, you can put a box around your base and your negative exponent, move it to the opposite location, in this case, from the denominator, move it to the numerator. So that'll be x cubed divided by 1. 1 is left behind. But in this case, anything divided by 1 is the same thing. Right? X cubed divided by 1 is just x cubed. To prove this, or to show another example of how this works, let's work with numbers yet again. This will be our last example here. If I have 2 to the negative third power, it's really the same thing as that divided by a 1, which is important because it helps to show how I'm going to move this from my numerator to my denominator. Okay. It's going to be 1 divided by 2 to the third power now. The negative exponent becomes positive, and that's going to equal 1 divided by 2 times 2 times 2, we've already shown, is 8. If you check a calculator, 1 divided by 8 will give you the same decimal as 2 to the negative third power. This is how you can show that that holds, that this rule works. And same thing if you started with the reverse, if you started with the negative exponent being in your denominator instead of your numerator, again, box around the base and its negative exponent, move that into the opposite location. Okay. With the opposite sign now for the exponent, it becomes positive. You can divide by 1, but really dividing by 1 doesn't change anything. And 2 cubed is 8 divided by 1, or 8. Okay. And that's what's going to happen if you try to, once again in the calculator, take 1 and divide it by 2 to the negative third power. You should find that the answer is 8. So that's going to end it for this video. In the next video, I'm going to go over some more complex problems in which you have to apply more than one exponent rule for the same expression. So I will look to see you then, and I hope this video helped.